we also want to investigate the asymptotes of the function f of x equals x cubed minus 1 over x squared minus 1. From our previous analysis on the points of discontinuity and their nature, we actually can see that x equals 1 is a point of infinite discontinuity. Therefore, we can immediately conclude that x equals minus 1 is vertical asymptote. And as we have, I will just here start and we will complete as we move on the graph. So if this is minus 1 and this is the line, so this is minus 1, we know that from right it goes to positive infinity, and from left it goes to negative infinity. So this is how the graph will look like. I will just use another color. So this is how the graph is going to look like, and this vertical asymptote helps us. So we need to figure out what is now for positive x. So what happens with the function here, and what happens with the function on this side. So how does it look like? For that reason, we can use the so-called oblique asymptotes. And those are the straight lines of the form y equals kx plus n, where k is obtained as the limit when x approaches plus infinity and also minus infinity separately, f of x over x, and n is obtained as limit when x approaches plus minus infinity, f of x minus k times x. So these two formulas, or these two limits, again, you can see that limits are very important. We are going to use to find the oblique asymptote. So let us start with k. K equals limit. We will do plus infinity, and then we will conclude about negative infinity. F of x, which is, we will just write the simplified version. That is x squared plus x plus 1 over x plus 1 over x, which is limit when x approaches infinity, x times x plus 1, x squared plus x plus 1, and you can already see that this is going to be one. Comparing the highest degrees, they are the same, so this is 1. So k equals 1. K equals 1. So this is 1. And now we need to find n. So n is limit when x approaches infinity plus infinity, f of x, which is x squared plus x plus 1 over x plus 1, minus k times x. K is 1, so just x. We will bring this to the same denominator, this x squared plus x plus 1 minus x times x plus 1 over x plus 1. That is limit when x approaches infinity. That is just 1 over x plus 1, which is 0. So n equals 0. Therefore, y equals x is oblique asymptote as x goes to infinity. Same thing, and this is your homework. So homework, y equals x is oblique asymptote as x approaches negative infinity. So this is your task to prove this. I will not. Will take just, it's a matter of writing, but that writing you can understand more. So what does that mean? We have more information about the function. So we can sketch the graph proxima. So we know that at, I'll just take the ruler. So this is 45 degrees, and this is y equals x, and that is our oblique asymptote. Then we have at 1 vertical asymptote. This is minus 1, sorry. And then at 1 we will have a discontinuity, but a removable one. So we will see how to figure out that. And now, just for the sake of completeness, f of 0 is 1. So that can just help us. So this is f of 0. We know that the function has here, so it goes down. Then at 1, it has empty circle, so it has cut, and then it approaches, it aligns to the oblique asymptote as x goes to infinity. This here is 3 over 2. And here it aligns to both asymptotes. You can extend this, and this is our f of x. So you can see that we can gain a lot of details and information only using domain. We can use continuity and asymptotes, which are actually limits. So we didn't use any differentiation here. Of course, our graph is approximate. We can see that this here is minimum. This here is local minimum and local maximum. And differential calculus can help us figure out where exactly these points are. So what are their coordinates? But for the sake of sketch of the function, we only used a domain. So to find the domain, continuity, and limits, that is asymptotes, because asymptotes are actually obtained by the limits. And you can see how powerful these three things are and important in study of real functions. Let's see. Okay, so that's it for this function. It seemed at the beginning pretty, and you can see here also we have now a complete image of how the function looks like. So one function which on the first sight looks simple, but there is yet a lot of analysis to be done there in order to obtain proper information about it. Thanks for watching.